What is a fraction? That's a big question. And most of us have a pretty good idea at this point in our lives what a fraction is, and we generally think of fraction as a part of a whole. We tend to be pretty fond of like pies and pizza when we talk about fractions, and so I'll draw my best circle here, kind of a pizza pie, and part of a whole. So here's my whole, and then I have, I go to cut my pizza there, and I say, okay, here is 1/2. And a friend of mine might argue, says, wait, you get to cut it, I get to pick. I pick that one because that looks like the bigger half. Oh, darn, that's a good point. So let's modify this a little bit. Equal part of a whole. So I want to make sure that when I do cut the pizza in half, that this side here is the same size as that side right there. I have some other examples here I want to look at. When I talk about equal parts, there's two different ways to think about that. So the pizza is one idea, and that's a whole area. So here is a wall, let's say, and I painted some of my wall red and some of my wall green here. And from the picture, you might be able to discern that it looks like I painted 2/3 of my wall red. So I have a bunch of red paint, and I claim that 2/3 of this region here, this rectangle, this wall is red, and 1/3 of it's green. Now, painting something is different than, say, having a group of people. So let's say this right here is a group of people with red hats. And I have 1, 2, 3, 4 people with red hats, and I have 2 people with green. There's 6 people altogether, 4 out of 6. We're kind of used to reducing fractions at this point in our lives. So we would say 2/3 of these people have red hats on. And a person is different than paint. Right? I can pick out an individual person, but I can't pick out an individual piece of paint on my wall. That's kind of weird. What do you mean by that? Area is this idea of continuous in mathematics, and an individual is this idea called discrete. So continuous versus discrete. So these, in my opinion, are two different versions of part of a whole. Part of a whole area, part of a whole group, and the parts have to be equal. So each person is an equal part, and each part here is equal. So 2 equal red parts to 1 equal green part. Now, a different idea than part of a whole is a position on a number line. So here I have 0, and I measure over and I say that's 1 over there. Then if I cut this number line up, I can find a spot, a point on this number line. This point right here, and that point right there is where 2/3 lives. If this is 0 over here, and this is 1 over there. So that position, right? It's not part of a whole, it's just a position along some distance. So that's another way to think about a fraction. It's a different way in our reality that we represent fractions. And again, it's not quite the same as 2/3 of a group of people, right? It's this position in space. Now, there's another idea that's still pretty different than part of a whole. If I think of a fraction as division, because it is division, 2/3 is really 2 divided by 3. I could write it with that slash, 2 divided by 3, or the division symbol. This one right here, 2 divided by 3. And in this case, I have 2 things, like maybe these are 2 candy bars. And I want to divide them for 3 people. How much does each person get? Well, my claim is each person gets 2/3. So here are my 2 candy bars here. Here's 1 candy bar right here, and here's the other candy bar right there. And I claim I can make a special cut through the candy bars such that this is what person 1 gets, and this is what person 2 gets, and this right here is what person 3 gets. And how much do they each get? They each get 2/3 of a whole candy bar. So it's actually a division problem. We have to take 2 things and break those 2 things into 3 pieces. Right? 2 things, 3 pieces. All right, and these all have a similar idea in common. That's still a similar theme, right? That theme is the idea of 2/3. It's just there's different ways to view 2/3 physically. Next, ratio. And this one looks, in my opinion, dramatically different than the others. My claim is that this ratio right here represents 2/3. How is that? Well, if I look at the ratio of green things to red things, then I get a ratio of 2 green things for every 3 red things. That's, again, a different way of thinking about what a fraction is. Other places we use ratios, when we talk about miles per hour, that is a ratio. It's not a part of a whole, but it definitely involves a division, and a division is a fraction. When I make pizza, I use flour and water and yeast and a little salt and oil. But if I just consider say the water versus the flour in my pizza dough, and I consider that as a ratio, which is a fraction, I use 1 cup of water for every 3 cups of flour. So there's a ratio of 1 to 3. So I have 2 different things I'm comparing here. I'm comparing with division, and it's another way we use fractions. And if somebody says, well, hey, I got a lot more flour. I have 10 cups of flour to use. How much water would I use? I can use ideas of fractions to figure that out. So in reality, we use fractions in many different ways. And I think there's 5 major ways: part of a whole area, part of a whole group, position on a number line, an actual division problem, and a ratio. And based on that, we add, subtract, multiply, divide, solve equations with fractions in certain ways because of what a fraction means. This idea of part of a whole, this idea of division. More on operations soon.